Okay, have you ever stopped to think about the fact that everything around you, everything, is run by a hidden set of rules? From the light hitting your screen to the atoms that literally make you who you are. Well, today, we are diving deep into the beautiful, mind-bending blueprint for those rules, a concept called Yang-Mills theory. So let's just start with a huge question, a real giant. What if all the forces in the universe, which seem so different and chaotic, what if they all danced to the same tune? What if there was one single, elegant, unifying rule behind it all? That's the epic quest we're on today. Now, to really appreciate just how game-changing this idea was, we have to hop in a time machine and go back to the 1950s. Physics was in a strange place. On one hand, scientists were brilliant, but on the other, they were staring at a deep, really frustrating puzzle. So here's the lay of the land back then. You had electromagnetism, which was gorgeous. It was a single, elegant theory that worked perfectly, all based on this beautiful idea called gauge symmetry. Now, that's basically just a fancy way of saying that the laws of physics stay the same no matter how you look at them. It's a fundamental kind of consistency. But then you had the nuclear forces, and that was just pure chaos. Seriously, physicists called it the particle zoo because they kept discovering all these new particles and none of them followed any obvious rules. It was a total mess. So you can almost hear the question echoing in the halls of universities, right? Could we take that one beautiful idea, that symmetry that made electromagnetism so perfect, and could we somehow stretch it or generalize it to finally tame that wild particle zoo? And then, right in the middle of all this head-scratching, came the breakthrough. A totally revolutionary idea from two physicists who saw a path right through the middle of all that chaos. And bam! 1954, two physicists, Chen-Ning Yang and Robert Mills, publish a paper that just changes everything. They proposed a brand new kind of symmetry, a more powerful, more complex version of the one in electromagnetism. And that idea, well, it turned out to be the key that would unlock the secrets of those messy nuclear forces. They introduced what we now call a non-abelian gauge theory. I know, it sounds super complicated, but the core idea is actually something you understand intuitively. So in the old theory of electromagnetism, the order you do things in doesn't matter. It's abelian. But Yang and Mills said for the nuclear forces, the order absolutely matters. Think about it like this. Putting on your socks and then your shoes is very, very different from putting on your shoes and then your socks. That simple difference, that non-abelian property, has world-changing consequences. Because this is where things get really, really weird. This new math made a shocking prediction, something that completely changed our picture of how forces even work. Okay, quick refresher. To get this prediction, we gotta talk about force carriers. The best way to think about them is like a game of catch. To interact with something, you throw a little particle at it. We call those particles gauge bosons. For electromagnetism, the particle being tossed back and forth is the photon, the particle of light. Simple enough, right? But here's the absolute bombshell from Yang-Mills theory. It predicted something that had never, ever been seen before. It said that the particles carrying the nuclear forces didn't just interact with matter, they had to interact with each other. The balls in our little game of catch could actually attract and repel the other balls. This is a massive difference. Just think about photons, the particles of light. They couldn't care less about each other. You can cross two flashlight beams, and they just pass right through one another without a second thought. But the carriers of the strong force, which we now call gluons for a very good reason, are totally different. The theory said they have to be sticky. They're constantly interacting with each other, pulling and pushing on other gluons. It's like imagining a world where beams of light could stick together or bounce off each other. That's the strange new reality Yang-Mills described. And here's the kicker. This bizarre, almost unbelievable idea of self-interacting forces, it wasn't just some mathematical curiosity. It turned out to be the actual blueprint for how our universe is put together. And here it is, the incredible payoff. That one single, abstract idea became the key to understanding almost everything. You can see it right here. Yang-Mills theory is the mathematical engine behind both the strong nuclear force, which glues atomic nuclei together, and the weak nuclear force, which is in charge of radioactive decay. That one paper from 1954 laid the foundation for two of the four fundamental forces of nature. Just incredible. And the theory didn't stop there. It made two huge, totally counterintuitive predictions that have since been proven right time and time again. First, something called asymptotic freedom. This means that at insane energies, like right after the Big Bang, the strong force actually gets weaker. And then there's the flip side, confinement. At the lower, everyday energies we live in, the force gets so ridiculously strong that quarks are permanently trapped. You can never, ever pull a single quark out by itself. It's impossible. But, as mind-blowing as Young-Mills theory is, it's not the end of the story. Not by a long shot. In fact, it continues to throw some of the deepest challenges imaginable at scientists today. And we're not talking about some dusty old academic problem. This is an active million-dollar mystery. It's called the mass gap. We know from experiments that the particles from this theory have mass. We can measure it. The problem is no one has ever been able to prove it using the theory's own math. It is so tough, so fundamentally hard, that there is literally a million-dollar prize waiting for anyone who can finally crack it. And its importance has just exploded far beyond particle physics. The mathematical language of Young-Mills theory is now an essential tool for cosmologists studying the Big Bang, for scientists working on new materials, and even for pure mathematicians, where it's completely revolutionized entire fields like geometry. When you really step back and think about it, this quote just nails it. Yang-Mills theory isn't just a bunch of equations that describe stuff. It's a fundamental language for reality itself. It connects these elegant, abstract ideas of symmetry and geometry to the raw, untamed power of the forces that build our entire universe. And it's a beautiful reminder that beneath all the chaos and complexity we see, there just might be a simple, elegant rule running the whole show.